Our last rule is power of a product rule. So our first example on your paper is xy to the fourth power, which means we have xy 4 times. So since we have x's and y's, we can look at our like terms. So we have 1x, 2, 3, 4, which would be x to the fourth power. And if we look at my y's, 1, 2, 3, 4, so y to the fourth power. This would be my answer. My next example is going to have numbers and letters in it. So we have 2x to the third power. Sorry, I wrote that wrong, so let me fix that. So we have 2x, the 3 should be outside of the parentheses. So that means we have 2x 3 times. 2x times 2x times 2x. So now we need to look at my like terms, and we have 2 times 2 times 2. So we have 2 3 times, so 2 to the third power. And then we need to look at my x's. 1, 2, 3, x to the third power. And we know that 2 to the third power is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we can write this in a more simplified form of 8x to the third power. So you can write it either way. And our last example that you have on your paper is 6x to the third power to the fourth power, which means we have 6x to the third 4 times. So we have 6 times 6 times 6 times 6, which would be to the fourth power, then x to the third 3 times. So x to the third times x to the third times x to the third times x to the third, 1, 2, 3, 4. Since this is x to the third, we can break this down more to x times x times x, then x times x times x, x times x times x, and x times x times x. So I have 6 to the fourth power. Let me make that a little smaller. 6 to the fourth power. Then this would be x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My final answer would be 6 to the fourth power, x to the 12th power.